And welcome to everyone joining us today, either live or maybe watching the recording. This is the beginning of a series of webinars that we will be doing with our Open IoT Challenge sponsors. The goal really is for all the participants to understand what our sponsors can help you with, either in terms of tools, of hardware, software, libraries, and whatnot. So we are starting today our series with Tim from Bitreactive, and we're going to hear about what Bitreactive can help you with if you're an IoT developer, and even more so if you're participating to the Open IoT Challenge. So Tim, welcome. Thanks for joining us. And yeah, why don't you briefly introduce yourself and tell us what Bitreactive is all about?
Thank you, Benjamin. Yes, as you said, I'm Tim Jagenberg from Bitreactive, a Scandinavian company from Trondheim in Norway. I'll switch over to my slides and give you a brief introduction about us, what we do, and what we can offer to you, what might help you. Benjamin, can you see the presentation in full screen?
Yes, sir.
Okay, perfect. Yes, we are a company from Trondheim, Norway, a small team of 7 in the company. Trondheim is the tech capital of Norway, so to say, which is also what brought me here. As you might hear, I'm from Germany. We have the National Technical University here in Trondheim, which is a big driver of innovation. And we also have SINTEF, which is a not-for-profit research organization here in Norway. Aside those two, we also have a couple of IoT companies in Trondheim. Nordic Semiconductors is here from Trondheim, has the headquarters here. ARM does the development of the graphics chipsets, the Mali chipsets here in Trondheim. So a lot of the graphics chipsets in your mobile phones will be from Trondheim or developed in Trondheim. And we have Atmel, now Microchip as well, which developed the AVR processor for the Arduinos that started as a master thesis at NTNU. So yeah, just to advertise a little bit for Trondheim, if you're interested in tech, it's definitely a nice city to be. And then about ourselves, about Bitreactive. Originally, we started with a tool for visual IoT development, which I will show you later, which is probably interesting to some of you. And then at the same time, we're using our own tool to develop assisted living solutions, supporting people with, for example, dementia. And that's the thing I will talk about first. What do we do in assisted living? Just a brief overview. In assisted living, you often have lots of devices installed in the home of, for example, elderly person or demented person, which might be related to detecting faults or when they leave the apartment without being allowed to. Instead of going directly to the cloud in this assisted living, it's usually the case that these devices talk to a local gateway, the smart gateway, which then again talks to the cloud and to the healthcare provider. And exactly this gateway is what we focus on. Here we're developing software which can interact with the various sensors and devices locally, and then sends the processed information to the cloud. One such solution we developed is bed monitoring. We're using a bed sensor, which is basically an accelerometer to detect if somebody is in bed or not. And based on that information, we can, for example, send warnings if some person leaves the bed at an unexpected time in the middle of the night, for example. And a very similar solution, more targeted at institutions, at elderly care homes, is this monitoring where we can display the status of multiple beds at the same time on a dashboard screen. And again, we can send warnings if somebody leaves the room unexpectedly, so that the caretakers can have a look and can help them or can figure out what is wrong. And then to the tool which our company revolves around and which we are based on, Reactive Blocks. It's also a result of NTNU. It started as a PhD thesis at the National Technical University. And the idea is to help you keep your code organized. As probably a typical example, you tend to have chaos of wires which might resemble your code. And by organizing it a little bit clearer, it makes it a lot easier to handle the different tools you have. And that's exactly what the Reactive Blocks does. We have a graphical interface based on the Eclipse rich client platform, which allows you to model your application as a UML activity diagram. And then based on that diagram, you can automatically generate the Java code for this application, which can then be deployed to IoT gateways, like, for example, the one from Eurotech, which you see here. We also offer a quite tight integration with Kura, so you can directly generate applications which can be deployed to Kura gateways. And then I'll go a little bit more into details how it works. So on the main level, you have an application which is plugged together from individual blocks. And each of those blocks can, again, be a combination of blocks. So you have a hierarchical system which helps you break down complex applications into smaller parts which are easier to maintain. And it also helps you to develop a system together with multiple developers. Each developer can be responsible for one sub-block, which then gets integrated into a bigger application. Each of these blocks has a so-called contract, which defines how the outside world can interact with each block. As you can see in the bottom right corner, each block has a couple of input and output pins, and the contract defines in which order these pins can be called, in which state the block will be after calling a certain pin, and so on. So you have a formal definition of how you can interact with a block. Based on these blocks, we can then create a visualization of all potential states, and you can navigate through this graph of different states. So you can move forward and backwards in the simulated execution of the application, and you can see which states you are able to reach from a given state. And you might also find problems where you, for example, exit an application without having shut down a block properly, for example. And things like that can also be picked up automatically based on the contracts and the state analysis. We can highlight problems. This is such a case. Somebody was using an MQTT block in the application, and the application is being shut down without properly stopping the block. So the analysis shows a warning and explains why this happens. And it also allows you to jump into this state visualization and directly identify why something is going wrong in this point. Behind this whole graphical tool, we built an extensive library of building blocks, which you can use straight away. Most of them are licensed under the Eclipse public license, so they're free to use for you. And then we have multiple tools for simple things like buffering, creating interfaces to other applications via CoAP or, for example, MQTT. And as I will show in a short example, we also have tools to integrate, for example, with the camera. So I'll switch over to Reactive Blocks itself. This is what it looks like, just a normal Eclipse application. You have the normal project explorer, and with Reactive Blocks you have the Blocks Explorer, which shows you the Reactive Blocks projects, like for example this time-lapse project. And here you can also navigate the libraries which you have. So here you can have a look around and see which blocks you might be able to use in your application. But let's open one of these projects, for example, the time-lapse recorder. And then you see the application straight away. In the lower left corner, there's the analysis window, which does not show any problems, which is good. And then we can have a look at the application. This little blue dot is always the starting point, and the blue dot with a black dot inside is the exit point of the application, where the application shuts down again. So once we start, we go into the grabber, which is the block which interacts with the camera. We set a resolution and we tell it which camera to use. And then as soon as it's initialized, as it got access to the camera, it starts all the other blocks in this application. For example, a periodic timer, which once a second tells the grabber block to take a picture, or the recorder block, which is responsible for recording the captured pictures into a video file, and also another periodic timer, which I think once a minute tells the recorder to store the captured pictures as a new video file. And then at the same time, once the grabber has captured a picture, it is sent to the recorder, and it's also sent to a block which simply displays it in a frame in a window, so we can see the live window, the live picture. And then this is also used to stop the whole application. When I close the window, this pin fires is stopped. This stops the grabber. Once the grabber is stopped, it closes the recorder, and then the application shuts down. In order to compile this application into source code, I simply have to compile here. It generates Java code, and it also generates a separate project here in Eclipse with the suffix exe. So here we can have a look at the generated code. Yeah, it's just standard Java classes, so you can compile it and run it as usual. We also auto-generate a launch configuration, so you can start it right away. And that's what I'll do. Let's see if it works during a video conference. Oh. Dang. It's probably because I'm using the webcam. I cannot access my secondary webcam. I'll try a quick fix.
Well, maybe you can try turning Hangout.
I'll just use the default camera. Let's see if that works. Rebuild. Run. Yep, my video camera is activating. And I'm getting a video frame. Is the video frame visible on the presentation? Well, I assume yes. So it is now recording pictures once a second, and these pictures are then assembled into a video file and stored in my project. As soon as I close the window, again, everything is terminated and the application shuts down. And here we can actually see the generated video files based on those pictures. So relatively straightforward. And if we want to modify such an application, it's just a matter of dragging in additional blocks. For example, this motion recorder is a slight variation of the time-lapse recorder. It only detects, it only captures pictures if motion is detected. So the modification is a simple matter of dragging in this motion detection block, which again is based on off-the-shelf blocks from our library. And then you get a time-lapse recorder which only records pictures which actually have a change in them. I'll do the same quick fix here. Instead of using this camera, I'll just use the default camera. And I'll compile it into Java code. And then I can run this application. Wait for the first frame to appear. I need to move a little bit so it actually detects something. There we go. If I stay still, the video is not recorded. And as soon as I move, it actually picks up the changes and records individual frames. And again, after closing the window, the application shuts down. So that was a simple overview to give you an idea what Reactive Blocks can do. Maybe I will also briefly highlight this navigation through the state space. Now I have initialized the application, and by using my cursor keys, left and right and up and down, I can go through potential steps. So right now in the initial phase, I can only do one step. I go into the initialization. Then I'm in the initializing state. And here I can already see there are two potential outcomes in this black bar at the bottom. And with the left and right cursor key, I can switch between the potential outcomes. So either the initialization is okay, and I go into the big horizontal bar on the top to start all the other blocks. Or the outcome might also be that the initialization failed, as we saw before when I was trying to use the wrong camera. And then it goes into a show error block and exits the application. So in this way, I can easily navigate through potential states and then execute this step. And I can see what might happen. Each of the potential steps is highlighted in yellow. This, so far for this part. The presentation. If you want additional information, you can just have a look on our website. The documentation for Reactive Blocks is on the reference bitreactive.com. We also have a specific documentation for this Open IoT challenge, which you find under this address, which requires a login, which you can just request from Anne. And also, as a participant in the Open IoT Challenge, you have access to a free license of Reactive Blocks. So you simply contact Anne, our sales representative, and we will give you a free professional license for the Open IoT Challenge. So long from my side.
I don't see any questions so far in the chat, but we can certainly wait a couple of minutes, especially since there's quite a few people actually watching us. So yeah, can you maybe in the meantime tell us, team, what's next for Reactive Blocks? Like, are there new things coming for IoT developers?
One thing which comes out of our own use will be containers. We have started to use containers a lot internally to deploy our solutions to gateways. And we already have an internal prototype which is creating a Docker file for our application. So it becomes easy to deploy a Reactive Blocks generated application as a Docker container, either on a device or maybe on a server as well. It depends where you want to use the application.
I see.
Another thing we're also developing internally currently is a Maven build. When you create a project with Reactive Blocks and you generate the source code, it will also generate a coding POM file, which allows you to build the project with Maven instead of with the Eclipse integrated build.
Right, okay.
But those are still in development, so I guess they will be released in a month or two.
I see. Okay. So yeah, I don't see any questions still. So yeah, let's wait one more minute. If you're watching us live, please make sure to send your questions now. You can always defer them to later on in the comments on the video or on our Slack channel. But yeah, better use the opportunity of having Tim here. Tim, why would you like the participants to build with? I mean, that might be a super like wide questions, but are there any particular kind of applications that you would be excited to see the participants build on top of Reactive Blocks? Like I really like your example with the camera, but are there other, I don't know, kind of sensors, kind of technologies you would like people to be using? My guess is Reactive Blocks could be pretty interesting for some kind of scenarios, like a software-defined network, almost like, I mean, the ability to model maybe some complex workflows for routing IoT messages, doing filtering, edge analytics.
Yeah, that would be an application. And it would fit well with what we provide in the library. We have many components for typical messaging services like MQTT or CoAP. So it would be easy to, for example, develop a bridge between different messaging services in Reactive Blocks.
Yeah, makes sense. There's a question from Martin. He really likes the fact that the code is written in Java. Any potential problem that you guys may have detected on the performance of the applications? Anything that people should be like careful about when it comes to building Reactive Blocks app?
The code itself is relatively straightforward. If you go through the generated code, it's a state machine which breaks down the blocks into individual steps and executes them. If you need higher performance, especially on multi-CPU platforms, you can, of course, code your own threading, which comes with the usual synchronization problems. But what we are doing quite successfully is we are using a microservice architecture where multiple Reactive Blocks applications are interacting via a message bus. So each individual application is relatively small, easy to maintain, and runs in its own process. So we're making good use of multi-CPU platforms, like, for example, the Raspberry Pi 3, which already has 4 cores. So no, we haven't seen any performance issues. It's the standard Java code.
Yeah, makes sense. Cool. That's great. So I hope this answers your question, Martin. Martin says, thanks for the presentation, by the way. And I say the same. So I think, I mean, unless there's other questions, but I don't think there is. Tim, I would like to thank you for your time. I think you will be around either on the Slack channel, or like people can easily find you over email if they have questions about Reactive Blocks. Yeah, if you're watching the recording, you have all the links to get to. If you're a participant to the challenge, you have access to Reactive Blocks, like Tim said, and yeah, just in general, check it out. I hope many people will be using it for their projects. And well, thanks again to Bitreactive for sponsoring this year's challenge. I'm really looking forward to seeing what's next for all the projects, and I'm sure you feel the same, Tim.
It's always been quite interesting what kind of solutions people come up with.
Yep. So yeah, I mean, have a nice day, team, and have a nice day, everyone watching us today. Bye.
Thanks a lot, you too.